Hi guys, so this video looks at 8E, paying off a loan. Now I'm not going to read through the writing through here, you can pause the video and have a look through there yourself. But basically what we're going to do is look at what we did previously where we're adding interest to the loan, but what we're also going to do is pay the loan off in regular installments, just like we would in the real world. So eventually over a period of time, n years or n months, our loan will come down to zero. So if you have a look at the little diagram over here, I love this diagram. The green part down the bottom is our loan, the principal amount, and then over time, well, let's not look at the time part first, let's look at the orange part, which is the interest. So this loan was for $1,000, oh sorry, $1 million because it's in K after the end of it, and we're paying an extra $500,000 in interest. So we're starting at a higher amount that we would owe. And over the time period, which looks like it's about, it's over 20 years, 20 to 30 years, possibly closer to 30, we're paying that loan down to zero. And that's what we're going to have a look at today. But we're going to be paying equal installments each period in time. I just want to make a note that we need to have a look at HSC questions as well as the questions below when we get a chance, because those questions don't just relate to dollars, they relate to other things as well. So a home loan is usually paid off in regular installments with compound interest charged on the balance owing. This is not the same as the superannuation in the last exercise. We don't start out calculating it the same way, and we're paying off a regular installment, generally monthly, sometimes yearly, and we're going to call that M. Okay, so M is going to be our monthly repayment. R, like before, is going to be our rate. So here we have a sum of $15,000 and it's borrowed at 6% per annum and paid back at regular monthly intervals over 3 years. I want to find the M, or find the amount of each payment. So we've said M is the payment. R is 6% per annum, but we're changing it to months. So divide it by 12 and then change it out of percent to get 0.005. 3 years is 36 months, and we're looking at this formula still. So what we're going to do is sort of start similarly to the last question, but we're going to take off a repayment of M each month. Each month, interest is applied, and then M is repaid. So with the first month, we want to think of A1 as being, into this formula, $15,000 times our 1.005 to the power of 1. So that $15,000 that we're borrowing has only been increased in value by that 1 month's amount of interest. And then we're going to make a repayment in that month as well. And we're going to do that for each month. But what's going to happen is at month number 2, we're going to get our amount that we had before at A1 and apply interest to that amount for 1 month. And then we're going to take our repayment out. But this A1 is this value here. So I'm going to substitute that value in, which is right here. And I'm timesing it by this 1.005, which is this amount here, and taking off the M. So when I expand that out, I'm expanding this to the first term and this to the second term. I get 15,000, 1.005 squared, minus 1.05M, and that minus M stays there. So what I've done is just neaten that up a little bit by factoring out the M out of those last 2 terms. Now I'm going to go on and look at some more months just so we can see that there's a pattern. We want a pattern, and quite easy to pick up the pattern, but let's have a look at it again. So in month number 3, the amount that we have is going to be A3, which is going to be our previous month's amount, which is this amount here, with another section of interest added, and we're taking off our repayment. So I'm going to sub in my A2 for A2 here, and that's that large part here, times by 1.05 minus M. So I need to expand out the 1.05 again like before. So I get a cubic, and I've expanded here, and I've got a 1.005 and then a squared term, take away M. And what I did then was just factor the M out of all of these, and I've kind of missed a step in your working, but if you were to expand that out, neaten it up, pull the M back out, that's the term you're going to get in there. Okay, so we can see that there's a pattern. When we've got the third year, there's a 3 there. Then we have minus M, and we've got all terms here starting with 1, going up, then by a factor of 1.005 to a 2, which is 1 less than a 3. So I'm going to increase that pattern and go, well, we're going down to A36 because there's 36 months that the loan is going to go for. So we're going to have 15,000 times the 1.005 to the 36 minus M. And I'm going to make this pattern increase from the last pattern, and we're going to go to 1 less than 36, which is 35. And that's our final pattern. And that would probably be a really good thing to memorize that pattern and know what's happening in there, because that might help us with a question later on. So after 36 months, we say the loan is repaid, because that's the aim, is that enough of these M's have been taken out so that over that 36 months, our loan's paid off. So at 36 months, we owe 0. So I'm going to pop a 0 where the A36 is in here and leave the rest of my sequence like that. And then I'm going to rearrange it. So I'm going to go plus this to both sides, so that moves over to the left. Let's zoom in here. So I've got M times my sequence is equal to 15,000 times 1.005 to the 36, and I'm going to divide by this sequence. So I've got M is equal to the top line, and then I've got a GP on the bottom line. Now I've just worked out the sum of that GP like we've been doing for over a week or 2 now. First term is 1, that's my A. My common ratio is 1.005, and I've got 36 terms. It ends in 35, plus that extra 1 is 36. I'm popping that into my sum of a GP formula. So I get these values here. Pop that in my calculator, and I get that my sum to 36 is 39.33, etc. here. And that's the bottom line here. So I've popped that in there and written it nice and neatly down here, and pop that in my calculator, and I've got my M is $456.33. So if we're paying that off every month, our loan will reduce to 0 after our 36 months. Let's go to the next page and the next example. This example says that Zach buys a computer for $3,000. The computer store charges 9% per annum for a 3-year loan, and repayments do not have to be made until the 4th month. Okay, so it's a little bit different, this one. The 9% we're going to take to 0.09. We've got to think though, let's read the question. We're looking at the loan being paid monthly, because we're talking about months here. So I need to make this 0.09 into a monthly amount. So I'm going to divide that by 12. So I get 0.0075 as my rate, and my new time period is 36 months, so 3 times 12. And we're still working with this formula here that we've been working at for our compound interest. Now what's going to happen is interest is still being added to our loan for the first 3 months, but we don't actually have to take an M out or a repayment until we get to the 4th month. So if part A says how much does Zach owe after 3 months? So that's basically just going to be 3,000 times 1 plus R, and here's our R to the 3, and we get $3,068.01. I've worked it out incrementally as 1 month, another month, another month, and popped my value from before here, just for interest sakes, but that's our value. So after 3 months, that's what he owes. We want to work out what are his monthly installments. Okay, so this one gets a little bit more complicated now. Okay, so I've worked out from A1 again. So we said A1, we've got $3,000, and we're timesing that by 1.0075 to the power of 1. We're not making a repayment there. After the 2nd month, we're going to get our 1st month's payment and increase that with our interest as well. So I've got my 1st month here and popped it in here and times that by 1.0075. And I've got this one here. Similarly for A3, I put my A2 in there and increase that with my interest. So there it is there, and times that by my interest again. So we're back to this top one we had up above. They were the first 3 months where we had to have no payments made. Now we're going to start making payments in the 4th month. So the 4th month, we're going to have our previous month 3 times by the interest factor and take off a payment. So I've got my A3 from up here, pops it in there, times it by 1.0075, got a 4, take off my M. So that's my first in the series involving the M's. Now I've gone and done a few months because we can't really pick up the pattern there, so we need to pick up a pattern. Unless you know the pattern, the more you've done of these, the more you'll be able to just write that pattern out if you get good at them. So the month 5, we're going to get month 4, times it by the interest, take off a payment. So I'm going to pop this month here in here. Now there's an M involved, times it by the 10075, take off the M. I'm going to expand the brackets with this interest factor to times into here to get a power of 5, and to times by the M, or the minus M, to get that in front of the M, and I take off the M. Then I've neatened it up and factored out my M. So 3,000 times my interest factor to the power of 5. I've taken an M out of the last two terms, and that's what I've got. So you can see here that we could pick up the pattern here. We've got the month 5, and we've got a 5 here, and we've got two terms here. So 5 and two terms there. So maybe there's enough to make up a pattern. I've gone and done it again, and then I've got my power to the 6, and I've increased by another term that's squared. So let's have a look. So I guess what I can see here is I've got 6 as a power here, 2 as my main power here. I've got 4 values that are different. 5, take away my highest power here, there's going to be 4. So you're going to still have that on that bottom line as a power with the pattern. So I'm going to have as A36, it's going to be 35 times my interest factor minus M. Oops, sorry, I've just zoomed out there. But what we're looking at is the pattern, and I'm going to be copying that pattern from above, because that's how we're going to work this one out. So at the 3,000, when A was 6, we had a 6 power. A is 36, so I've got a 36 power. Minus M, I've got my series inside that is growing up until the power that is 4 less than my 36. But I should have 33 terms in there. It's just that my first one is 1. And if you think about what was happening in this question, we were not paying any repayments for the first 3 months. So 36 months, take away 3, would give us 33. And there should be 33 terms in there that are matching our 33 payments of interest. So just be really careful with that, because the power is only 32 because our first one is going to be 1. So what we also know is that after those 36 months, our loan is repaid. We don't have any more money owing. So A to the 36 is 0. So I popped a 0 here where I've had my A36. And here's my equation from above. And I now need to rearrange this equation to find a value for M. Now, last time I just rearranged it straight away, but this time what I've decided to do was, well, let's just figure out what our sum of our GP is here. So it's a GP of A being 1, R being 1.0075, and we've got 33 terms. Because our R is bigger than 1, I've popped it into that formula. And when I've done that, I've ended up with this value of R. Of our sum to 33 terms. So when I pop that back in there in terms of our sequence and rearrange it, this is the equation I'm solving. M being equal to 3,000 times 1.0075 to the 36 divided by that sum, which is this value here, and I'm going to get my repayments of $105.30. The last one was saying how much are we repaying all up. So he's paying $105.30 every month for 33 months. So when I times those together, that's my final amount that I'm repaying. And if you have a look back at the question to start with, the loan was for $3,000 for his computer. So Zach's computer was $3,000. If I zoom back down to that number that we just looked at, our repayments in total are going to be $3,474.90. So he's got $474.90 in interest.